example is like this compound here, pyrrole. We see it has carbons and hydrogens in it's a cyclic compound, but again, it's also bonded to an non-carbon compound, which is nitrogen, similar to all these other structures, yeah? So cyclic compounds are divided into two. We have heterocyclic compounds. These are compounds that are made up of other atoms that are neither carbon or, that are not carbon, like nitrogen, oxygen, or sulfur. And then we also have homocyclic compounds. These are compounds that are rings, or they're rings in nature, but they're not bonded to other atoms like nitrogen, oxygen, and sulfur. So the heterocyclic compounds are broken down into two. There's aromatic and non-aromatic. So aromatic are the ones that are like saturated forms. They do not contain, the carbons are not fully saturated. That is, they don't have the maximum number of hydrogens. Non-aromatic, like pyrrolidine, the carbons have the maximum number of hydrogens. And then for homocyclic compounds, we are very familiar with them. We have benzenes, cyclopentadienes. Yeah, these, I'm sure you're very familiar with them. So this is exactly what I've just explained, that hetero, we mean, by hetero, it means different. And different is that it has other atoms that are not carbon, like oxygen, sulfur, and nitrogen. Sometimes you can even find silicon, boron, selenium, and beryllium as well, yeah? Though we haven't encountered any of those, yeah? The heterocyclic exist as 3, 4, 5, 6 multi-membered rings. The smallest being the 3 members, and then the 3-membered rings, and then like they continue, and they continue being, yeah, you understand. So the stability of the heterocyclic rings increases with the number of carbon atoms. That is, the smaller rings are less stable due to strain, whereas the ones with the more carbons are more stable because they have less strain. Then these are some of the common heterocyclic compounds. I know you might have come across them, especially pyrrole, also tetrahydrofuran. These are very common compounds. You might have come across them when you're going through the papers. So we are going to learn how to name these compounds step by step. Also, we are going to learn like, what else are we going to learn? Yeah, mostly the nomenclature, because most of the questions that I came across were just asking about how to name them. So we are going to learn how to name them today. These are also other heterocyclic compounds. You might have seen them around when you're going through the papers, especially these 6-membered rings. They're very common in exams. You can also find these polycyclic rings, but not as much as these just single rings. Am I going too fast?
Kwa tu sawa.
Aye, sawa. So classifications of heterocyclic rings, kuna 3-membered, 4-membered, 5-membered, 6-membered. Those are the most common ones. Also 7-membered rings, 8-membered, not as much. So examples of 3-membered heterocyclic compounds, kuna kama hizi oxirane because it has now oxygen as its as the heteroatom. Aziridine because it has nitrogen. Whenever you see as means nitrogen. Thyrene, every time you see a thi, you know there's a sulfur somewhere. So this is for the 3-membered rings, yeah? And another thing to note, these rings exist as saturated and unsaturated forms. The saturated forms being that the carbon has the maximum number of hydrogens, whereas unsaturated, the carbons don't have the maximum number of hydrogens. You'll see double bonds. So whenever you see a double bond in a structure, unajua hiyo structure, you know that structure is unsaturated. Is that okay? You guys have to say something. If you
That's
keep
okay,
quiet,
yeah.
That is good. That is good. That is
Yeah, that
okay.
is good. It's Divya who keeps quiet all the time. I think we should kick her.
Okay.
She's
Could
a
you
paid
please?
member. She's a paid member. Order in
Yeah.
the house. Order in the house.
Higher. So,
Okay. Could you please repeat that statement kindly?
oh, so I'm saying, you see these heterocyclic compounds, they occur as saturated and unsaturated forms. When we say saturated, we mean that compound the carbons have the maximum number of hydrogens. Let me show you an example. This is what we say, this one we say is saturated because there's no double bonds anywhere. Whenever you see a double bond, that structure is unsaturated because some of the carbons don't have the maximum number of hydrogens. Anywhere where you see a double bond, unsaturated. But when you see there's a structure is looking like this, there are no double bonds anywhere, it's saturated. Is that fine?
Yeah, that's okay. Thank you.
Yeah.
Because
Yeah. So unaona kama hizi three, okay, now these rings also, sometimes they can have more than one heteroatom. Like you see the way here, this structure, let's say pyrazine. Pyrazine has two nitrogen atoms. There are times where you'd find a nitrogen atom and an oxygen atom. There are times you find a nitrogen atom and a sulfur atom. So they exist in both forms. So this is what this slide is talking about, that when you find, okay, a three-membered ring with only one heteroatom, for oxygen, oxirane. What is this one called? Nitrogen, aziridine, and then Evo. Now, for more than one heteroatom example, we have diaziridine. Di because it has two, as stands for nitrogen, so diaziridine, two nitrogens are present in that structure. Oxaziridine, ox means oxygen, as nitrogen. So you know this structure has an oxygen somewhere and a nitrogen somewhere, oxaziridine. Yeah, so that's how you can tell. So the list goes on. If I explain this right now, you might not be able to understand them well until we at least watch the video, at least learn how to name them. It would be useless to just have you guys go through them. So importance of heterocyclic compounds, yeah. They're present in different structures. Example, by this one, they're essential for life. They're present in, I think this is hemoglobin, if I'm not wrong. Chlorophyll, DNA, RNA, you'll find them everywhere in alkaloids, antibiotics. In antibiotics, you find penicillin. I mean, in penicillins, you find beta-lactam rings. Cephalosporins also the same. Amino acids, you find heterocyclic rings literally almost everywhere, especially in these, you see these psychotic drugs. I noticed this is where they even like to ask, like you can see here diazepam, you can even tell two as means there are two nitrogens there. So like it's so important to know these heterocyclic compounds. So the nomenclature now is divided into two, but I don't think you'll be asked this in the exam. Mostly they just ask you to name a structure. So I'm going to show you a video that will help you easily understand, so that now we can move easily and faster. We can even finish early. Can you see my screen?
Yeah.
Heterocyclic rings.
Okay, so now we can watch the video.
In easy way. What is a heteroatom? Let us take one example of a ring like this, and it's a well-known ring, that is the benzene. Now this benzene is made up of carbon and hydrogens. But if you take another ring like this, and here you can observe a nitrogen. So what is this nitrogen? Nitrogen can be called as heteroatom. So any atoms other than this carbon and hydrogen can be called as heteroatoms. Now this ring is one of a heterocyclic ring having a nitrogen as an heteroatom, and this is called as pyridine. Similarly, another structure is here you can observe two heteroatoms. This is one heteroatom and this is another heteroatom, and this is nothing but pyrimidine. In this way, we can write so many types of heterocyclic rings, but how we can remember these heterocyclic rings? If you carefully observe, both of these rings are having the same prefix pi and they're having the same suffix I. So we can remember the heterocyclic rings by using few of the prefixes and by using few of the suffixes. So in this video, we will go with the heterocyclic rings, how we can remember and any possible suffixes as well as the prefixes present for the heterocyclic rings. Suffix for the heterocyclic rings. So we can have a broad heterocyclic nomenclature, but here we are going to see how easily we can remember this heterocyclic rings by using few of the suffixes. The suffix for the heterocyclic rings can be given based on the ring size. What is the ring size and what is the suffix if it is on?
Okay, so just as I was telling you, we have different ring structures, ring size structures, and they exist as either unsaturated or saturated. So when we are naming them, we need to be aware of whether the structure is unsaturated or saturated. For example, you see, let's say you're dealing with a three-membered ring. You cannot, a three-membered saturated ring, you cannot add irene in place of iridine. That's why I also explained, like, it's really important to be able to differentiate the saturated and unsaturated. So, okay, can continue.
Unsaturated and if it is saturated. But here we have shown the suffixes for the saturated rings, which are having the nitrogen. So if the ring size is 3, and if it is unsaturated, that is the irene, and if it is saturated and nitrogen containing ring, it is the iridine. Similarly, 4, that is EAT, and saturated etidine. 5, ol, and if it is saturated, olidine. And 6, I, but there is no suffix for the saturated ring. From the ring size 6 onwards, the saturated rings will not have any particular suffix. Similarly, the ring size 7, the suffix, if it is unsaturated, epine, but there is no suffix for the saturated. Similarly, 8, osin, 9, onin, and 10, ec. So if we remember these suffixes, we can easily build what is the name of the heterocyclic ring system. And another important thing is the replacement nomenclature that we use along with the heterocyclic rings. For example, if nitrogen is there, nitrogen is actually replacing the carbon of the aliphatic ring. So here we can use few other terms based on the heteroatom. So if nitrogen is there, we can use the prefix eja. Oxygen.
Okay, so just take a minute and note this down if you're writing it somewhere, so that it can be easy for you to just, when you see them, chap chap. Or take a screenshot, whatever is easier for you. That's fine, I continue.
Yeah.
Aye.
Wait. Yeah, you can go on now.
Aye. So,
Sulfur is a dia and phosphorus as phosphor. So in this way, any of the heteroatom can be indicated by few of the prefixes. So by using these suffix and prefix, now let us go with the discussion of how easily we can remember the heterocyclic ring systems. So let us start with the first one, 3-membered ring. So the simple 3-membered ring containing the nitrogen as the heteroatom. So what is the name of this ring system? Because the nitrogen is present, we have to use the prefix eja plus. Because it is a 3-membered unsaturated ring system, so the suffix is the irene. So
okay, so you see, it's unsaturated because of this double bond here. Aye, we continue.
eja plus irene. So this is nothing but the Ag ring. So nitrogen containing heterocyclic ring system, which is unsaturated, is the Ag ring. Similarly, if it is saturated, so again the prefix is eja plus. Whenever it is saturated, we can use the suffix iridine. So plus iridine. So eja plus iridine, that is the agiridine. Aziridine is one of the ring system present in few of the drugs like the thiotepa. Thiotepa is one of an anti-cancer agent which is having the aziridine ring system. Similarly, another example is the three-membered heterocyclic ring with oxen as the heteroatom. So now here we have to use the prefix oxa plus again the irene. So oxa plus irene, it gives the oxirine. Similarly, if it is saturated, then what happens? In the previous example, we have seen that the suffix is iridine if it is saturated, but that is a suitable for the nitrogen containing ring systems. But this ring is not having the nitrogen, this is having the oxygen. When the ring is having heteroatoms other than the nitrogen, we should use a different suffix. So if other than the nitrogen is there, then if it is saturated, we have to use the simple suffix as A. A indicates like alkanes, they are saturated. Now this ring system is oxa plus. In the irene, we have to replace the ine with the A. So oxa plus irene. So here A indicates it is saturated. So oxa plus irene, that is oxirane. Oxirane is the three-membered ring system containing oxygen and completely saturated. Similarly with the sulfur can be indicated by thia plus it is a three-membered ring system and unsaturated, so that is irene. So that is thia plus irene, thiirene. Similarly, this ring system here, thia plus if it is saturated, we can write the irene plus A, that is a irene. So thia plus irene, so that is a thiirene. Now let us go with the four-membered ring system.
Guys, are we able to follow properly?
Yeah.
Okay.
Yeah.
The four-membered ring system again containing the nitrogen, and here we are going to discuss we have the heterocyclic ring system which are more existing in the nature or synthetically. So this is the one of the ring system. So here what is the need? Again we have to use the ETA, and because it is a four-membered ring system which is saturated, we have to use the ETD. So ETA plus ETD, that is the AGTD. Similarly, another four-membered ring system with the oxide. So here we have to use the oxa. So here ET is the suffix for the unsaturated ring system. But because it is saturated, now the ET becomes ete. So oxa plus ete, that is a oxetane. And next is the five-membered ring systems. So this is the one of the five-membered ring systems containing the nitrogen, and this is another heterocyclic ring system having oxygen, and this is another heterocyclic ring system with the sulfur. Now what are the names for these three ring systems? Here, the first one is the pyro. So here, pyre is one of the term we are going to use in many of these heterocyclic ring systems, and ol is the suffix for a five-membered ring system. So that is a pyre plus ol, pyro. But for
Okay, so I noticed when we reach this from the 5 and 6, mostly the prefix that is used is this here, PYR, pyre. So once you see PYR or AZA, you just know you're dealing with nitrogen.
second one, the name is the furon. Here we are not using any suffix like the ol, even it is a five-membered ring system. That means this ring is having an exception and it is commonly known as furon. Before developing this nomenclature, it is well known as a furon, so the name is going to be retained as furon. Similarly, third one is the thiophe. So these three ring systems are having a different names like the pyro, furon, and thiophe. Even all these are belonging to the five-membered ring systems. But based on these names, we can write the names of the higher heterocyclic ring systems. Now this is another example of the five-membered ring system containing the nitrogen, and it is saturated. And similarly, another ring system is having a five-membered ring system with oxygen and saturated. So what are the names for these ring systems? For the first one, it is a saturated form of the pyro. So here we can use the suffix like the olidine. Olidine indicates a five-membered ring system which is saturated. So pyre plus olidine, that is the pyrrolidine. So pyrrolidine is a saturated five-membered ring system containing nitrogen. Similarly, for the second ring, which is a saturated form of the furon, there is no specific prefix and suffix, but simply we can represent it as tetrahydrofuran, commonly known as THF. Tetrahydrofuran is the saturated form of the furon. In this way, for few of the heterocyclic ring system, the common name is well distributed. Next one is the five-membered ring systems with two heteroatoms. So this is one example of the 5-member ring system with 2 nitrogens as the heteroatoms. And now what is the name of this heterocyclic ring? So if we compare this ring system with the pyrrole, what is the difference? Pyrrole is having only 1 nitrogen and this is having the 2 nitrogens. So this can be written as pyrrole is having an extra nitrogen which can be indicated by aza. So which can be incorporated in between the ring. So we can write like pyr plus aza plus 4. So pyr indicates one of the nitrogen and aza indicates another nitrogen and ol indicates a 5-member ring system. So now this is the pyrazole. So pyrazole is the nitrogen containing 5-member ring system with the nitrogens at the first and second positions.
Guys, are we still following through?
Yes.
Okay.
And this is another ring system. And here, what is the name of this ring system? So this ring system can be written as imide plus aza plus 4. So here imide again indicates a nitrogen containing ring and aza is the extra nitrogen and ol is a 5-member ring system. So this is the imidazole. How can you remember this pyrazole and imidazole? We may be confused with that. Pyrazole is having the nitrogens at the first and second position or first and third position. It can be easily remembered that this imide indicates here where letter M is there, M indicates like the meta position, that means the third position. Just like the aromatic ring systems or the meta.
So, you see, when we are counting, we begin from here. So when we start here, 1, 2, 3, 4, 5. The position of this one, whenever this is ortho, meta, para. Whenever this heteroatom is at the meta position from the first carbon where you're counting, you'll use this term here, imide. So whenever you see imidazole, pyrimidazole, wherever you see imide, just know whatever heteroatom they're talking about is in the meta position. That's fine, yeah?
Yeah.
All right.
Para, M indicates here the meta position. That means the second nitrogen is present at the meta position to the first one, that is the third position. So whenever M is there, then it indicates the third position. So imidazole is having the second nitrogen at the third position. In this way, we can easily differentiate the pyrazole and imidazole. Pyrazole is 1, 2, imidazole is 1, 3. Similarly, another ring system is having oxygen and nitrogen. What is this? So here the oxygen is present at the first position and nitrogen is present at the second position. Always we have to give the preference to the oxygen, then to the nitrogen. So here the oxygen and nitrogen are present at the first and second position, and oxygen can be indicated by oxa and nitrogen as aza, and it's a 5-member ring system O. So this is an oxazole. The heteroatoms are present at the first and second position. So this can be written as 1,2-oxazole. So this 1,2-oxazole is commonly known as isoxazole. So here you have to remember that isoxazole, the iso indicates first and second position. If we see another related ring like this, now here oxygen is present at the first position, whereas nitrogen is present at the third position. So this is again oxa plus aza plus 4 with the first and third positions having oxygen and nitrogen. So this is the 1,3-oxazole. So this 1,3-oxazole is commonly known as oxazole. Oxazole is the ring where heteroatoms are present at the first and third position, but in the isoxazole, they are at the first and second position. Similarly with the sulfur, again we can write the prefix for the sulfur as the thia plus aza plus 4. So this is the thiazole, and if we indicate the position, this is the 1,2-thiazole. Similarly, this is nothing but thiazole with the first and third position. So this is the 1,3-thiazole. Just like the oxazole, here the first ring can be called as isothiazole and second ring can be commonly called as simply thiazole. So thiazole indicates first and third position, isothiazole indicates first and second positions. And again here, sulfur should be given more preference than the nitrogen. Next one is the 5-member rings with 3 heteroatoms. So let us take one example here, sulfur, nitrogen, and nitrogen. So sulfur is at the first position, and then the nitrogen at the second position, and third nitrogen is at the 5th position. So here the heteroatoms are present at the first, second, and 5th positions. And the prefix is the thia, and here 2 nitrogens are there. Therefore, it is diaza, and it's a 5-member ring system, that is 4. So this is the thiazole, but whatever the numbering is 1 to 5. So 1 to 5 thiazole. This is again another ring system. Now here the sulfur is at the first position, whereas nitrous.
So we are done with the nomenclature. Literally all these slides that follow from here are just explaining what was in the video. It's going to be very easy for you to go through this. Even when you're going through the questions, it's going to become very easy. I think we can now just pick up from here. So the same thing that was being explained, whenever we have a 3-membered ring with 1 heteroatom, let's say we have nitrogen, becomes aziridine when it's saturated, unsaturated azirine. The same. I believe we can just go through this very fast now. And then Thiotepa, at some point there was, he spoke about Thiotepa. This is the compound Thiotepa. You see it has 3 heterocyclic rings which contain nitrogen, 3-membered heterocyclic rings that contain nitrogen. So yeah. 4-membered, 5-membered, 4-membered. So 4-membered rings with 4-membered ring, this ring here is the ring that is present in penicillin and cephalosporins. And then what else? Oh yeah. And then, oh yes, and then for furan, the other name for furan is oxol. Okay, I don't know if I'm saying it properly, but yeah, oxol. So furan or oxol, because sometimes you might be given maybe like in a multiple choice question and you don't find furan. So you might also, you should be aware of these names, oxol and thiol. 6-membered rings, numbering. Okay, now we come to numbering. So the heteroatom is designated number 1 and the substituents around the chain are numbered so as to have the lowest chain. So wherever there's a substitution, we want the substituent to have the lowest number. So our heteroatom will be the first. So let's try and name this one, yeah? So we start counting from where the heteroatom is, here where nitrogen is. So 1, 2, 3, 4, 5. We see there are 2 methyl groups in carbon 2 and carbon 5. So it becomes 2,5-dimethyl pyridine. Pyri because we have a nitrogen here, the heteroatom nitrogen. Idine because it's an unsaturated 6-membered ring. Similar with this 7-membered ring here, we start where the heteroatom is, 1, 2, 3, 4, 5, 6, 7, and then 1, 2, 3, 4, 4-methyl. Yeah, 1, 2, 3, 4. So I don't think this is 4-methyl. 1 azepine. Should be 5.
For that one, no. It you should count. What would say counterclockwise, not anti-clockwise. So it will. So
it should be this way.
So that, yeah, counter. Yeah.
1, 2. 1, 2, 3, 4. So here 4. The methyl group is in carbon number 4, and then also 1 azer because the position of where the heteroatom is, the nitrogen heteroatom is. Yeah. Higher. With 2 or more identical heteroatoms, the rings are numbered in such a way that the heteroatoms are assigned the lowest possible number. Exactly what I just said. 2 or more similar atoms contained in a ring are indicated with the prefix di, tri. These ones come in when, let's say, you have two similar atoms. Let's say the way we have here in this imidazole ring, we have nitrogen in carbon number 1 and carbon number 3. So it becomes 1,3-diazole. Now you see this imidazole, you should also be aware of this. You can write it as 1H-imidazole, but this imid, we we remove this imide and it just becomes iazole. So 1,3-diazole, similar with pyrimidine and also these other structures, yeah. But this only comes when you have like the same similar atoms, let's say nitrogen and nitrogen. Once you have, let's say, nitrogen and sulfur here, or nitrogen and oxygen, now it changes. It's not, you cannot use again di or tri. With 2 or more different heteroatoms, the numbering starts from the heteroatoms as oxygen, followed by sulfur, then nitrogen. So in a structure where you have 2 heteroatoms, you follow this sequence here, where oxygen will have more priority in comparison to sulfur, and similar with nitrogen. Let's use this as an example. We see here, we've said sulfur will have more priority than nitrogen. So we start counting from where sulfur is, followed by then the next heteroatom. So 1, 2, 3, 4, 5, 6. So 1, 2, thia, because of the sulfur, as because of the position of the nitrogen, and then as in because it's a 6-membered saturated ring. Let's say we have a structure that is partially saturated. When we say a structure is partially saturated, it looks something like this. You see, this one is fully saturated because all the carbons, they don't have the maximum number of hydrogen. But you see here, there are some carbons that have maximum number of hydrogen. So in such situations, you use fully unsaturated name with dihydro, trihydro, tetrahydro, etc. We give priority to saturated hydrogens when there are no functional groups. So when there are no functional groups, we give priority to the saturated hydrocarbons. The numbering will favor these saturated hydrogens before the unsaturated ones. So this structure here can just easily name it as azepine, as because there's a nitrogen, epine because it's a 7-membered unsaturated ring. But in the instance here, the way we have partially unsaturated, now we have to favor the saturated carbon. So we start our counting 1 from the heteroatoms, then 2, 3, 4, 5, 6, evo. So now we say 2,3-dihydro because now we are favoring this saturated hydrogen. So 2,3-dihydroazepine. Aze because of nitrogen. Epine because it's a 7-membered ring. Let's come here again. So if we start counting as 1, 2, 3, 4, 5. Similarly here, we want our hydrogens in the saturated carbons to have the lowest number. So our counting will follow this direction. So 1, 2, 3, 4, 5. So 4, 5 dihydro because of these 2 saturated carbons here, dihydroazepine. Similarly with this one. So 1, 2, 3, 4, 5. We have a saturated carbon here. We have another saturated carbon here. So 2, 5 dihydroazepine. So similarly, it's the same thing that is being discussed here. Are you guys following?
Yep.
Very closely, very closely. Tunaandika notes.
Mnaandika notes kabisa.
Hey.
Okay.
Today we will discuss.
I think Comfort has a question.
Yeah, like I'm asking, there's if you go back to the notes.
Just a minute, let me share the notes.
There's the after imidazole,
There's a
okay.
just a minute, let me share the notes. Where?
Wait, I can't see the notes.
Wait.
I can't see them. But where there's the 5-membered ring of imidazole,
Mm-hmm.
there's one next to it. There's the second one, and then it says something like 2,5-dihydroimidazole. But then
Mm.
I can only see only the second,
Where?
the carbon in position number 2.
Is it this one?
No, next. Let's go down.
Mm-hmm.
After the example we did, on these polyunsaturated ones.
Mm-hmm. Oh, here.
This one.
Mm.
Yeah. So remember this one next to imidazole, it says 2,3-dihydroimidazole, but I
Mm.
only see the one in position number 2 as the saturated one. I don't see any other unsaturated one.
Mm-hmm. 1, 2. 1, 2, 3. I think this 3 here is for, wait. 1, 2, 3, 4, 5.
They've included the hydrogen on the other nitrogen because if you see imidazole, one of the nitrogens has a double bond, but then the next one you
Mm.
see like they've added that.
Okay, thank you.
Thank you so much, Hiral. So we continue.
Kinda.
Okay. Let's finish the second part of these rings, naming them from now the 6th and the rest.
Discuss 6-membered and higher heterocyclic rings in easy way. In our previous video, we have discussed the 3-membered to the 5-membered heterocyclic ring systems and what is their nomenclature. And today we will discuss the 6-membered and higher ring systems, what is the nomenclature and how we can give the numeric to these heterocyclic ring systems. Now let us go with the 6-member ring systems. So the simple ring system is the 6-member ring system with one heteroatom as a nitrogen. So already we have seen this is the pyridine. So pyridine is the nitrogen containing 6-member ring system. And if it is oxygen is present, then it is called as pyron. But in this pyron, second position is saturated because oxygen is having the valency as only 2. So the second position should be saturated. So here we have.
You see, this 2H here is coming from this part here. You see, this is a saturated carbon.
So going to indicate the point of saturation with its position and the letter H. So 2H indicates second position is saturated. So this is a 2H pyron. Again, here we are not following any particular suffix. So they should be well known with their common names like the pyridine and pyron. Now the 6-member ring systems with 2 heteroatoms. Now here we can add another heteroatom nitrogen at the second position. Otherwise, we can add the other heteroatom at the third position. And finally, we can also add this heteroatom at the fourth position. So nitrogens can be present at the first and second position, or first and third position, or first and fourth positions. Now, how can we write the name for these ring systems? Here, the first one is coming from the pyridine, and an extra nitrogen is there, like the azar. Just like in the pyrazole, which is a 5-member ring system, here we can apply the same logic. So pyridine, within the pyridine, we are going to introduce the azar. So pyrid plus azar plus ine. So that is a pyridazine. If you remove the agent, it's simply pyridine. So within the pyridine, we have introduced the azar because it's having an extra nitrogen at the adjacent position. So that is a pyridazine. And what about the second one? So just like the previous imidazole, so here pyr plus imid. Imid indicates that is a meta position, that is the third position, and the 6-member ring system, that is the ine as the suffix. So pyr plus imid plus ine. So this is the pyrimidine. So pyrimidine is having the nitrogens at the first and third positions. And what is the name for the last one? Here the one of the nitrogen can be indicated as a pyr, and the nitrogen as the azar, and suffix as ine. So pyr plus azar plus ine, that is the pyrazine. So here we have to remember that In the pyridazine, nitrogen is present in the second position, so we have written the pyrid. But in the pyrazine, it is present at the fourth position, we have taken only prefix py. So pyridazine is 1, 2 and pyrazine is 1, 2. So here we have three types of heterocyclic ring systems with two heteroatoms. So pyridazine, pyrimidine and pyrazine. Now let us go with the 6 plus 5 member ring system.
Okay, so now we are moving to something else. We are moving to polycyclic rings. A polycyclic ring is a ring structure that contains more than one ring. See, when benzene stands on its own, it's a heterocyclic compound. The minute it becomes bonded to another ring, now we call it a polycyclic compound. So we are doing both of them together right now.
Systems. So this is one of the 6 plus 5 member ring system. The 6 member ring system is the simple benzene, and second one is a heterocyclic ring system, which can be called as pyro. So simply it can be written as benzopyro, but actually this ring system is commonly known as indole. So indole is a 6 plus 5 member ring system with the nitrogen as the heteroatom. Similarly, another one is the benzene with the furan. When the benzene is going to be fused, it can be written as benzo plus furan. So it is a benzofuran. Similarly, this structure benzo plus thiophene, this is the benzothiophene. These names can be directly derived by using the whatever this term benzo when the benzene is going to be fused with the heterocyclic ring systems. Now let us take another example with the 6 plus 5 member ring system with two heteroatoms here. So what is the name of this one? So now here the whatever the heterocyclic ring system is the imidazole, which is attached with the benzene. So benz plus imidazole, that is the benzimidazole. So here we have not used the O because it is not easy to pronounce. So benzoimidazole is simplified as benzimidazole. Similarly, another one is the benzene with the oxazole. Now here this is the benz plus 1,3-oxazole. So that is the 1,3-benzoxazole. Really third structure with the sulfur. So again here benz plus 1,3-thiazole. That is a 1,3-benzothiazole. Now let's go with the 6 plus 6 member ring systems.
So far, so good.
Yeah.
So far, so
one of the
good.
6 member
Yeah.
Right, go ahead.
ring system with having nitrogen. So again, this heterocyclic ring system is commonly known as phenol. So here the nitrogen is present at the first position. If suppose the position of the nitrogen is going to be changed like this. Now here the nitrogen is present at the second position. So this is called as isoquinoline. So quinoline and isoquinoline. Quinoline is one of the important ring system present in the antimalarials like the chloroquine, mefloquine. And isoquinoline is one of the important ring system present in the smooth muscle relaxant like the papaverine. Now 6 plus 6 member ring system with two heteroatoms. So this is one of the ring system. So this is one ring where the nitrogens are present at the first and second position. This ring is commonly known as synole. And the nitrogens can also be present at the first and third position. Then this name of this ring can be derived from the base name quinoline. So because if single nitrogen is present, that is quinoline. So quinoline plus extra nitrogen as aza, that is quinazoline. Similarly, if the nitrogen is present at the first and fourth position, then it is commonly known as phenoxylene. You don't think that OX indicates oxygen is present. This ring is commonly known as phenoxylene, where the nitrogens are present at the first and fourth positions. These rings are well known with their common names. We have to remember as it is. Next one is the Ender heterocyclic ring system.
Okay, so we can pick up from there with the notes. Can you see my screen?
Yeah.
Yes.
Yeah. You want to try and name this structure? Seven-membered, fully unsaturated.
Yeah, we can try. Just wait.
Mm.
I'll let my senior Patrick go ahead first.
You don't throw me under the bus like that. I nominate Livia to take it over.
Where you answer your questions.
Hi. Yes,
So I'll
just
just
help
go with
them.
it being this as
I
right.
nominate you.
I'd go with it being as a kind in as a, I don't know, or if we are being like yeah, I'd say as a pin, as a pie, as a
Yeah,
pin.
as a pin.
This yeah, that's what I'd guess.
As a pin,
Yeah.
as a pin because as there's this nitrogen atom there, the first position, then it's a seven-membered ring. I see Divya has sent a picture in the group. You can check. Mhm. You can check for the structure. Yeah, it's very straightforward. So okay, in replacement nomenclature, the heterocycle's name is composed of the corresponding carbocycle's name and an elemental prefix of the hetero atom that has been introduced, literally what has just been explained in the video. Then what else? Oh yeah, for these, now when you're having polycyclic rings, you start naming first the heterocycle's name, the one with the corresponding, the one with the heteroatom, then followed by now the next ring. And then we have certain polycyclic compounds that already have the names like the common, okay, I don't know if they're common names or IUPAC names, but yeah, example, this structure here, very common in exams, naphthalene. Also, there's the one with the three benzene rings bonded together, anthracene. You'll see them very often. Mm. Okay. So, okay, this is literally what I had planned on presenting today. The rest of this is, okay, these are things I feel like you can read by yourselves, but also I didn't see them as much in the exams, so yeah. Sonia. I think Sonia will just pick up from here, and then we can do questions just before the end of the meeting. Is that okay?
Yeah,
It's
that's
fine.
okay.
That's
Yeah. let me post up the questions and then we can just go through them as Sonia is getting ready. Can you see my screen? Can you see my screen?
Yeah, we can.
Yeah, we can try and name this together. So we have structure A, a 5-membered ring. We see it's unsaturated nitrogen. So I believe most of us know the common name for this one. So this one is going to be easy. Surely, guys. Anyone?
I'd go with pyrrole.
Yeah.
Pardon the
Yes.
question.
Yeah, it's pyrrole. The second one,
Pyridine.
pyridine, yeah. Then the third one, we literally just saw it.
Naphthalene.
Naphthalene, yes, correct. Then the next one, piper,
Pyridine.
yeah, piperazine. And then E,
Diafuran.
nice. Let's look for more questions. Hmm. Okay, so I think the only thing we can do with this ring is maybe what is the general? Maybe the first and the second one, because the rest is medicinal chemistry. Can you try to identify compound A? Any idea? You can even Google it, it's fine. Faith, do you want to try? Okay, so the name of the compound is flufenazine, the antipsychotic flufenazine. And then what general name is given to compounds with three fused system like compound A? So the three fused ring system is a polycyclic. You can just look at it and see if you can identify the structure.
Yes, I'm seeing that flufenazine on Google has an OH group, but I can't see the OH group in this structure for compound A, unless, I don't know, do we ignore it or something?
So the OH is supposed to be here. I'm not wrong. I think the structure was not put properly. Yeah. The OH is supposed to be up here. And then the three-membered diffused ring is called phenothiazine. I've sent it in the group. You've seen?
Yeah.
Just
Mm-hmm.
so how do you know at all? You just cram.
Okay, so now you see the important thing to know is how to name them. After you know how to name them, identifying these heterocyclic, these heteroatoms becomes easy for you to even, like most times they won't ask you for, like they would just ask like, okay, partly you have to cram. Sorry to say, but partly you have to cram because there are times where you will not be able to name them. You won't be able to name the structure, even when you know the heteroatoms. So partly you have to cram them. But it's also very important to know the nomenclature so that when you're not able to, like, let's say you're not able to know, like to look at a structure and be like, okay, this is phenothiazine because there's thia, now the phenol because of the benzenes, and like just, it's important to know, like, literally there's no shortcut with this.
All right.
Let's scroll through and look for more questions. Well, my laptop wants to start acting up.
Guys, Jasmila said we'll pick from tomorrow.
Yeah, we can just pick up from tomorrow, since I can't reach Sony, don't think she's ready. We can just pick up from tomorrow, and whatever we've done today, you can go through it and try with different structures, because even if I continue, it's not going to be easy to get everything today. But with what we've picked so far, you can just try different structures, go through the questions, yeah, like